Continuing with our cavalcade of hormones, let's talk about control of pituitary, both hypothalamic and cerebral control. So, controlling the anterior lobe, as we've said before, releasing and inhibiting hormones from the hypothalamus travel down through the portal system to control anterior pituitary. Posterior, these are neuroendocrine reflexes. So, look at the term neuroendocrine reflex. This is basically a nerve signal coming to an endocrine gland, alright? So, it's a nervous reflex controlling an endocrine secretion. Hormone release in response to nervous system signals. So, for example, a suckling infant stimulates nerve endings in the nipple and the areola. Those travel to the hypothalamus. Then the signal is sent down the posterior pituitary. All right. Now remember, the posterior pituitary is just an extension, essentially, of the hypothalamus. So the hormones made in the hypothalamus, released from the posterior pituitary, oxytocin, will then produce milk ejection. Remember, prolactin is for producing milk. Oxytocin is for ejecting milk. So hormone release in response to higher brain centers. A milk ejection reflex can be triggered just by a baby's reflex. In other words, not just a physical stimulus, but a psychological stimulus. So this is pregnant women. It happens to them all the time. You know, they're out in public and they hear not pregnant women, women who have recently given birth, postpartum women, out in public, they hear a baby cry and they find themselves lactating. So there you go. You can see Mary and the little baby Jesus. He's probably saying, maybe I should turn this into wine. That'll get me to hell. And this was actually published in a Japanese magazine. Little baby suckling and holding an Oreo. Very controversial. A lot of people got upset about it. A lot of people just sense of humor, just not there. This is my friend Christine. What I was just talking about happened to her. Shortly after she gave birth, she got somebody to watch the kids so she could get out and do a little shopping, whatever, for a few minutes. Out in public, heard a baby cry, and she posted on Facebook, forgot the boob diapers. Normally puts little pads in her bra to try to soak up the milk. She forgot them, and there you see, just lactating, just ejecting milk like crazy in response to hearing some kid crying out in public. There's Christine. We used to go to baseball games. She's awesome. I love her to death. She's now an RN. Nice picture of Christine. There's a couple of milk bottles right there. She got breast reduction surgery, I'm pretty sure. Breastfeeding like a Jedi. Nice work, Mom. So let's talk about, again, controlling the pituitary. So neuroendocrine reflexes we saw. What about feedback from target organs? This is very important, and this is, we'll see, we'll probably talk about this later with respect to the guys who do the illegal steroids for bulking up, the bodybuilder, whatever. So negative feedback. An increase in target organ hormone levels inhibits release of the tropic hormones, all right? Or positive feedback, stretching uterus increases oxytocin release, causes more stretching of uterus until delivery. Consider the first one, negative, on the left. Look at the nice numbered steps here. Wasn't that considerate of them? So TRH comes from the hypothalamus, of course, down to the anterior pituitary, thyrotropin releasing hormone, causes anterior pituitary to release thyroid stimulating hormone. That tells the thyroid gland to release thyroid hormone. Now, on the one hand, thyroid hormone goes out into the body and has the effect that it's supposed to have. But notice, thyroid hormone also feeds back on the pituitary and on the hypothalamus. These are negative feedback loops. This is part of natural homeostatic control. You don't want the signal to go down there and suddenly you start releasing massive amounts of thyroid hormone nonstop. The thyroid hormone feeds back and says, okay, good, it worked. Hypothalamus, pituitary, the signal worked. We're doing good. We're sending out the thyroid hormone. You guys can relax a little, all right? We've got things under control, okay? It's necessary to moderate the responses. You don't want over-release of hormone. Remember, homeostasis. And positive feedback, the same thing. The baby's head hits the cervix dilates, all right? That causes the brain to release oxytocin, all right? and that then causes an increase in the contraction of the uterine muscles, and therefore it starts to push that baby out. That causes even more dilation of the cervix of the uterus. That then causes the hypothalamus to release oxytocin and so on. We got a positive feedback loop, and of course what breaks the loop? When you finally squirt that little parasite out, then that will stop it. So notice both positive and feedback loops controlling the pituitary here. So the pineal gland, peak secretion ages 1 to 5, by puberty 75% lower. The pineal gland is mysterious in a lot of ways. Some things about it are known, some things are not particularly clear. Produces serotonin by day, converts it to melatonin at night. Melatonin, I think we've talked about before, one of the so-called natural sleep aids. It basically promotes sleep. Pineal gland may regulate the timing of puberty in humans. Increases in melatonin noticed in conditions like SAD and PMS. So SAD, you may have heard of that before. People up in the northern latitudes, they can be affected by the darkness, all right? And it's a depression, seasonal affective disorder. It's a depression due to a lack of light. And that's caused by an increase in melatonin. Remember, pineal serotonin day, melatonin night. Too much darkness, too much melatonin increases this seasonal affective disorder. One of the interesting therapies is ceremony. What the hell? Phototherapy. In other words, big bright lights, so that people have to stay inside during, up there in all the cheese heads up there. Oh my God, it gets dark at 2 in the afternoon, and the sun doesn't come up until 11 a.m. That's an exaggeration, but so the indoor lights, and what that does is it inhibits the melatonin release, and apparently seems to help. Pineal melatonin also implicated in PMS. I'm not sure about that, but there's some literature on that. PMS, I'm fine, I hate you, I love you, I want ice cream. Come here, get away. Oranges? Yeah. So, yeah, in both cases, depression, sleepiness, irritability, carbohydrate craving. I think some of you have been there and know what I'm talking about. PMS. Your lady got PMS? What to do? Pray to God, move out of the way, sleep on the sofa. Message from the Ministry of Homeland Security. I do not have PMS, Lucy. Oh, lawless. Man, awesome. PMS, nature's way of leveling the playing field, much in the same way that an earthquake would level it. Okay. Caution, PMS zone. This is PMS, buddy. PMS 24/7. Oh gosh, I wish I knew her. 13 things PMS stands for: pass my shotgun, psychotic mood swing, perpetual munching spree, puffy midsection, people make me sick, provide me with sweets, pardon my sobbing, pimples may surface, pass my sweats, pissy mood syndrome, poor men suck, pack my stuff, or potential murder suspect. How funny my girlfriend thinks I am according to time of the month. Hilarious, really funny, funny, mildly funny, and meh. Not funny, really not funny. I hate you, fuck off, go die, I want to kill you. Yes. Remember guys, these are hormones. Cut your girl some slack, okay? Alright? Hormones, powerful, alright? If you had it, you would be intolerable. Studies revealed that the kind of face a woman finds attractive on a man can differ depending on where she is in her menstrual cycle. If ovulating, she's attracted to men with rugged and masculine features. If menstruating or menopausal, tends to be more attracted to men with duct tape over his mouth and a spear lodged in his chest while he is on fire. No further studies expected. PMS 666, I think that's one of my ex-girlfriends. As I recall, yeah. So, continuing in the cavalcade of endocrine glands and hormones, the thymus, we already talked about this when we covered the lymphatic system, so you know all about it. Located in the mediastinum, superior to the heart, involutes after puberty. Remember, it's huge in a little kid, and then it shrivels up after puberty. And why? Do you remember why? Sure you do. Because it's your childhood when you're training your immune system. Remember, the T lymphocytes have to go to the thymus to get trained, and they get trained by the hormones thymopoietin and thymosins, okay? That's really all you have to know here. I won't ask you more than that. I just want you to know thymus, a couple of thymic hormones, and you already knew what they did anyway. So the thyroid gland anatomy, it is the largest endocrine gland, has the two lateral lobes separated by the isthmus. And over on the left you see a picture of the worst nuclear disaster in the history of the planet. Happened in Russia. Maybe that's ringing some bells. Maybe you can investigate a little bit. But after nuclear disasters, the same thing happened in Japan. All along the west coast of the United States, people went to nutrition stores and bought up a certain nutrient. Think about that, and we will talk about that later. Why that all relates to the thyroid gland. The thyroid gland, largest of all the endocrine glands, it consists of these thyroid follicles. So look in the upper right, those big pink blobs are thyroid follicles, filled with colloid, lined with simple cuboidal epithelium. They secrete two hormones, T3 and T4. We're going to call both of those together simply thyroid hormone. So we're going to use the term thyroid hormone as a shorthand for T3 and T4. You don't really have to know any differences between T3 and T4 except why one is called T3 and T4. And that's coming up pretty soon, and you'll see it's very easy. But they both do the same thing as far as we're concerned, okay? So thyroid hormone has a calorogenic effect, increases heat production, increases production of ATP, therefore, of course, increases heat. Increases your body's basic metabolic rate, your oxygen consumption. Thyroid hormone is really a very, it's a stimulatory hormone. In a way, it works kind of like a growth hormone. It has to do with your overall metabolism and energy consumption and oxygen consumption, raises heart rate, raises contractility, increases respiratory rate, stimulates appetite, breakdown, carbs, breakdown of lipids and proteins. Again, think about what someone with hyperthyroidism is going to look like versus someone with hypothyroidism. Then these C cells, C is for calcitonin. They're also called parafollicular cells. These produce calcitonin. That was the hormone that lowers blood calcium, promotes calcium deposition by stimulating osteoblast. Remember, calcitonin really active only in children because children are growing, they're building bones. You don't have to do that once you're an adult. There are three hormones that affect calcium homeostasis, and you still have to know them. We covered those in Bio 201. We already covered them this semester in Bio 202, and now you're responsible for them again. So remember, PTH and calcitriol, also known as vitamin D, raise blood calcium. Calcitonin lowers blood calcium. All right. They're also called, these C cells, parafollicular cells, because they are para, the follicular cells. Makes sense, okay? The parathyroid on the posterior side of the thyroid, those four yellow dots back there, they release parathyroid hormone. So remember, parathyroid hormone, again, raises blood calcium by stimulating osteoclasts in order to do bone resorption. So PTH release increases blood calcium, stimulates the osteoclast, promotes also synthesis of calcitriol. Calcitriol, also vitamin D. And remember the important effect, calcitriol does some of the same things PTH does, but remember what else calcitriol does? In the small intestine, it enhances absorption of calcium. So that's why, like certainly in this country, when you buy milk at the grocery store, most cartons of milk are fortified with vitamin D. Why would they do that? Well, kids are growing. Kids need calcium in order to build bones. And in order to absorb calcium into your body, you need calcitriol. Therefore, they fortify the milk with vitamin D. Milk's got all the calcium. Vitamin D helps you absorb it. Makes sense to put them together, okay? Increases bone resorption, decreases urinary excretion. So the adrenal gland, our old buddy adrenal gland, remember it has two overall regions to it. On top of the kidney, adrenal, at the kidney, has the adrenal cortex and the adrenal medulla. So remember, the adrenal cortex, I've mentioned several times, has these three regions, the zona glomerulosa, fasciculata, and reticularis. The adrenal medulla, we talked about that in Bio 201. Remember, that's basically a sympathetic ganglion, releases the catecholamines into the bloodstream. So let's talk about them in detail then. The adrenal medulla is a sympathetic ganglion innervated by sympathetic preganglionic fibers. Remember those preganglionic fibers? Remember, those are the ones that are myelinated, the white rami communicantes. These modified neurons called chromaffin cells, they release catecholamines into the bloodstream. So remember, those are neurotransmitters, so they're involved in that way in the sympathetic response. But as neurotransmitters, they're only working within the confines of the nervous system. When they are dumped into the blood by the adrenal medulla, they now go everywhere in the body. They go to the heart, the liver, the skeletal muscle, and so on. And that's the most powerful effect of the sympathetic nervous system. The hormonal effect is much longer lasting and much more powerful than the effect as a neurotransmitter. So they increase alertness, anxiety, or fear. Think about it. The chupacabra has just come through the door. You're fighting for your life. So all those go together. Alert, anxiety, fear. You're in survival mode, okay? They're going to increase blood pressure, increase your heart rate, increase your oxygen consumption, your respiratory rate, raise your metabolic rate. They're going to inhibit insulin because we want to keep blood glucose high. So also then, to keep blood glucose high, what are we going to do? Gluconeogenesis and glycogenolysis, both of which will create more glucose in the blood, because we want the cells of our body all through the body to have plenty of glucose available right now. We've got to survive the chupacabra. Now what can happen here is that constant stress, chronic stress, can cause the medulla to stimulate the cortex. And we're going to see coming up with the adrenal cortex of why that can be a bad thing. You need your adrenal cortex, you need what it's releasing, but over-release, just the basic principle of homeostasis, is going to cause problems. And let's see what those problems are going to be. So again, constant stress causes the medulla to start activating the cortex, and then this whole next set of hormones are going to increase. So let's look at those. In the adrenal cortex, again, we have these three layers: the zona glomerulosa, the zona fasciculata, the zona reticularis. And I've been telling you to remember GFR, salt, sugar, sex. GFR, salt, sugar. Remember the two sections of the stands there at the football game. We're going to alternate GFR, salt, sugar, sex. GFR, not Grand Funk Railroad here, one of the horrible bands of the 1970s. But so what's going on here? These are all called corticosteroids. Why? Well, what's big and red and eats rocks? A big red rock eater. Why did Robin Hood steal from the rich? Because the poor don't have any money. Well, how much do earrings for a pirate cost? $1 an ear. So cortico, they come from the cortex. Steroids, because they're steroid hormones, okay? So mineralocorticoids from the zona glomerulosa, we're talking about aldosterone. Our old buddy aldosterone, Benny Dosterone's brother, aldosterone. Promotes sodium retention and potassium excretion. So sodium retention, remember aldosterone releases part of the renin-angiotensin-aldosterone system. We're going to retain sodium, water is going to follow, we're going to increase stroke volume, we're going to increase blood pressure, and that's what we need in the sympathetic response. Glucocorticoids, the zona fasciculata, we're talking about especially cortisol. It's going to stimulate fat and protein catabolism, so we're going to break down fats and proteins. Gluconeogenesis and release of fatty acids and glucose into the blood. What effect are all those going to have together? They're going to raise blood glucose. So cortisol raises blood glucose in several ways. This is, again, as part of your body's stress response, your adaptation to stress. If you're in a stressful situation, you need to survive, you need to have plenty of energy available, so we're going to increase that blood glucose. But here's a potential problem. Chronic stress means chronic high levels of cortisol. We keep stimulating the medulla. Medulla starts stimulating the cortex. We get high levels of cortisol. Cortisol can start having an immunosuppressant effect. So that's not something we want to do. I had to blow a moth off of my screen because it was annoying me. My mom had SLE, systemic lupus erythematosus. She had to take prednisone for her whole life in order to reduce the inflammation, but that also had a tremendous immunosuppressant impact on her. So these people are in a real bind. You know, you need the drug for one thing, but the drug has side effects that are really troubling. And then the sex steroids from the zona reticularis, androgen, including dihydroepiandrosterone, and testosterone converts to testosterone, and estrogen. So adrenal cortex, GFR, salt, sugar, sex, the corticosteroids, all right? These are powerful, powerful hormones. They have powerful, long-lasting effects. They're good unless they're out of control, all right? There you see in the bottom, salt, sugar, and the Sex Pistols. Oh, you kids, it's so tragic you missed the Sex Pistols. And on the far left, you also missed the Red Hot Chili Peppers. Their awesome album, Blood, Sugar, Sex, Magic. I remember when they played a concert when they had nothing but socks over their genitals. They were awesome. Okay, melatonin, secreted by which gland? Thyroid, pituitary, pineal, adrenal, or thymus? This should be easy. Pause the video, come back when you're ready. Yes, indeed, it's the pineal. All right? And there you go, Factory Butte. Isn't that a great name for it? Looks like those, have you ever been to the Midwest? Those factories that look like that? England, too, factories that look like that? Factory Butte. That almost looks like a painting, doesn't it? That's not Photoshopped. I actually don't even own Photoshop. I do enhance contrast and brightness on my photos, and that naturally enhances the color to some extent, but that's really the way it looked. It was a cloudy, stormy day, and Factory Butte just stood out in all of its majesty there. What an incredible structure. This is really the biggest town nearby. The closest town to Factory Butte is Hanksville, which I think has a population of 147, something like that. This is really the middle of nowhere. This is one of my favorite parts of Utah. It's so remote. There's really nothing there except things like Factory Butte. Okay, kids, I'll see you in the next video.